The quicker we get going, the quicker we get done. All right. Our objectives today. So we're going to talk about range, and then we're going to talk about something very important. We're going to talk about standard deviation. It is a topic that is going to carry us throughout the entire term. So it is an important topic. So we're going to talk about standard deviation. And we're going to talk about a pretty much useless topic called variance. And then we're going to discuss the empirical rule, which is also something very, very, very important. And it'll have a diagram that will make you all professional artists by the time we're done. So that is today's. It's lots of calculation. I'm also going to show you fancy schmancy calculation. So you will want your calculator, your fancy TI 84 or 83 calculator. You will want that today. If you don't have it with you, at least write down the steps as I walk you through them. Which reminds me, real quick here, I'm going to jump to my other screen and pull up my calculator so I'm not wasting time later. I love, love, love that I have this emulator. I know I say that every time, but uh-oh, there's a problem. It is not open in another window. Liar. Okay, so I thought I loved it. It is lying to me. Does stuff like this to me all the time. Okay, I'm going to get away from there. We'll deal with that later. That is future crisis problem. Okay, maybe. Yes. All right. Let me get my iPad, my trusty iPad. So I'm really hoping that today's lesson is slow enough that I won't lose battery because I forgot. So I need two cables because I need a cable from my laptop to the plug and I need a cable from my iPad to the laptop. Well, one of those cables is at school. It's at the college or at the high school. So let's keep our fingers crossed that the battery doesn't run out on the laptop from being drained from the iPad before I'm done. If it is, then you're going to have to get the end part from the video, but hopefully we'll be fine. Or I'll just try to notice and wrap it up real quick. Okay. So range is super simple. It's pretty much exactly what it sounds like. It is the range of values. So it is the, see here, I need the chat window up. There we go. It is the largest data value minus the smallest data value. So it is exactly that simple. It is just the largest minus the smallest. It tells us our range of values, tells us how far the smallest one is from the largest one. There's really nothing else fancy about it. That's the range. So for example, here's our data from travel times to work, and we just take our largest value, which is 43, or actually it's going to be on there for me. I'm not even going to have to math it. 43 minutes minus 5 minutes is 38 minutes. So there's a 38-minute range between the smallest and largest. It's that simple. Nothing fancy. Standard deviation. So standard deviation measures how spread out our numbers are. This is a very, very, very important topic. So we use the population standard deviation when it includes the entire population being studied. Now, there is a different way to calculate population and sample. So make sure when we're going through it, you pay attention to the different ones. So this is the Greek letter sigma. It's actually a lowercase sigma. And the more I draw them, the worse my drawings of them get, as with mu. So that is the Greek letter sigma, and that is the symbol for the population standard deviation. And you see a whole bunch of weird math right here. So basically what you do is you take each data value, you subtract the mean from that data value, and then you square what you get. The purpose of this is to get rid of negatives. And I know that there's much easier way to do this, but this is how they chose to do it. We have to do it exactly this way. And then you take the next data value, subtract the mean from it, square that difference. And you keep going through till you get all of the data values covered. Don't worry, you're only going to have to calculate it by hand a couple of times, and then you will never have to do it again. It'll be all calculator. If my lovely calculator will work, I'm going to pop over there again real quick. Okay, let me see if I can sign in. Fingers crossed this works. Okay, let's sign in with Google. If it'll let me. Man, things are moving slow today. Let's not move slow today. Okay, It's going to sign in. Battery power, are we still good? We're still good. Okay. All right, it looks like it's going to sign in. And I'm just going to leave it be and go back here. Okay, so after you take each data value, subtract the mean and square it, you add all of those together, and then you're going to divide by how many values you have. And then take the square root of that result. We're going to do it by hand, and it's going to make more sense to you. So let's actually do one. Okay, the first thing we're going to do is we're going to find the mean of our data set. So I'm just going to take my calculator, I'm going to add them all up and divide by 7 because that's how many data values we have. I mean, we did this the other day, but I don't remember what that number is. Okay, so our mean, we're going to call it 24.9. So I'm just going to write it right here. My mean is 24.9. See, we have a delay today. It is what it is. Next step is to subtract the mean from each number in your data set and then square the result. So I'm just going to do that right under the numbers. And then after that, we're going to end up adding them all together, but let's just do this one at a time. So I have 23 minus 24.9, and then square that result. Equals 3.61. I have 36 minus 24.9 squared. That's a big number, 123.21. Thankfully, we already know 23.
So, Melissa, if what if we did on accident, let's say you did 24 minus 3 or 24, have them in,
24.9 first.
yes,
It's not going to matter. You'll get the same answer.
get the same answer. Okay, I
Yeah.
just wanted to make sure
It'll
that,
just be positive instead of negative or negative instead of positive, but you square it so it gets rid of the negative anyway.
okay.
Yeah, so it really doesn't matter. I love it when things really don't matter. And you just can, like, it doesn't matter if you do things opposite. I love when that happens. 5 minus 24.9 squared. 396.01. And then 26. $1.21. Finally, 43 minus 24.9 squared equals 327.61. Okay, so I took each value, subtracted the mean, and then squared the result. Our next step, add all of these results together, then divide by the number of values in your data set. So I'm just going to add all of these values together. Just clear this out. I just did something wonky in my calculator. Happens more frequently than I care to admit. See, I just did it again. 47.61. Hope I got it right. I got 902.87. I'm going to divide by 7. Please let me know if you got a different number, if you're doing it along with me. When I divided by 7, I got 128.98. Sorry, I squished things together. If you're mathing along with me, let me know if I make mistakes, please, please. All right, the next step is to take the square root of that value. So I'm going to just take the square root of this. So the square root of 128.98. So it's second x squared. If you're taking the square root, hit the second button, which is your blue button, then the x squared button. And I got approximately, I'm going to make these approximate, 11.36. Let me know if you got the same thing or you got something different. Hoping my math's correct. So basically what the standard deviation tells us is it tells us that the average distance every value in our data set is from the mean is 11.36. That's what it's telling us. So that tells us kind of how spread out our data is, because if that number is bigger, if the average distance from the mean every number is bigger than, like, say it's 15, then you know that our data is going to be more spread out because things are on average 15 whatever away from our mean. If that number is smaller, then most of our values are going to be crowded around the mean. So the bigger the standard deviation, the more spread out your data is. We're going to do another one. Questions?
The population mean, all you have to do is just add up everything and divide it by the number. That's all the population mean is.
Yep, that's the same thing with sample mean. The sample standard deviation is going to look a little bit different, but for population standard deviation, you also divide by the number. But mean, both population and sample, add them all up, divide by how many you have. The only thing that changes is the symbol with mean.
Okay.
Okay. I'm sorry. I hope I didn't confuse you more. All right. Questions before we do another one? All right, let's go to another one. So we are going to, what I did was I took I made it two separate spots. So a deviation, I want to explain this because there's a lot of people that change the terminology when you're answering questions. If you're talking about deviation without the word standard, the deviation refers to the distance one value is from the mean. So if, like, for example, we remember, if you all remember that our mean for our test scores was 79. So 82 minus 79, that's 3. So the deviation of Michelle's score from the mean is 3, but that's not a standard deviation. A standard deviation refers to the spread of your data or the typical distance a value is from the mean. So you only can use the word just deviation if you're referring to one value and how far it is from the mean, if that makes sense. But when you are using data that's used by computing all of them, that is the standard deviation. So the value we're going to calculate is the standard deviation, which refers to the typical distance each of our values is from the mean. The only reason I need to state this is because there's a lot of people in past classes that they just kind of drop the word standard and they just call everything deviation. And so I want to make sure that you guys don't make that mistake. All right. So we're going to do the same thing. So I would like you to start ahead of me and try. So the first column, you're just going to subtract. So I would do 82 minus 79 equals 3. And then what would happen over here is this would be 3 squared is 9. So go ahead and do each of these and work your way down. If you get stuck, go ahead and look up. I'm not going to speak. And go ahead and look up if you get stuck. I would like you to try as much of it as you can on your own.
Melissa, what did you say? Can you say standard deviation one more time refers to?
Standard deviation is the spread of your data. It is basically the typical distance every value in your data is from the mean. So you're like averaging the distances each of the values are from the mean is basically what's happening.
Okay.
But if you just call it the spread of the data, I will absolutely take that.
And then in terms of when we're completing certain assignments and it asks for find the population mean or sample mean is indicated, you kind of just want to see the symbol for sample or population. So if sample, it's X bar, and population, it's the mu symbol equals.
Yes. Yes,
Okay,
and
that's
yes, basically what's happening. Yes, because I know that in the homework, I don't know if you're working on the hand-in homework. The hand-in
exactly.
homework tells you to calculate the population mean and to calculate the sample mean. They're calculated exactly the same way. Just one of them is going to be
Right.
mu equals something, and the other will be X bar equals something.
Cool.
Perfect.
So I think I missed something. Why are we subtracting from 79? Is that the mean?
We're trying to find,
Oh,
yeah,
yes, the mean.
79 is the
Okay.
mean. We calculated that
Okay, got it.
Tuesday. And so
Okay.
I just happened to remember this one.
Okay.
I
thank you.
didn't remember on the other data, but yeah, we calculated the mean on Tuesday and we got 79 for the test scores. Some numbers I'm really good at remembering, other numbers not so much. I still remember my childhood telephone number.
Me too. That's because we didn't have cell phones that kept it all like stored.
I still remember my ex-husband's social security number. That's a weird one to memorize. I would never use it for anything, but it's fun to freak him out occasionally, letting him know I
Yeah.
have it. I just said that on recording. That's not the case. I just lied. I would never do anything nefarious. It's just a weird number that I have memorized.
Big Brother's listening, so
Big Brother is listening.
the government.
I would never do it's
You are a good
in my
human. We
nature.
know you.
Not even in my nature to do stuff like that. I would be so scared of getting in trouble. I could never do anything. There we go. All right. Sorry, I talked through your math, y'all. Okay. I'm hoping if you're not all done with that, once you get all done, we're going to add all of these together. So remember, that is the next step, is to add them all together and divide by the total number of observations you have. So we have 10 tests here. So you're going to add all these numbers together, then you'll divide by 10, and then you take the square root of your result.
You don't subtract one from the number?
Not on this one. This one is still a population.
Okay.
Where this is a whole class of 10 kids.
Okay.
So their population is whatever this class is, class of students. It's a small class. Well, we're going to do the sample in a minute.
Yeah, gotcha.
What's 96.4? I don't know where my division is. Apparently I can't divide. Golly. I was waiting for someone to correct me on that one. Okay, there we go. I don't know if you all are there yet. I got a standard deviation of 9.82. Yes, Guy?
Yeah, don't you usually round to the second decimal place?
That's what I did, 9.82.
Yeah, okay, it says there's an 8 after that too, so I thought you would round up to 3.
No, because the 1 goes to 2.
Okay.
Yeah.
Okay.
Yeah. So 9.82. So I have approximately 9.82. So the average distance each score is from the mean is about 9.82. So the standard deviation, we're going to use it in lots of different ways later on. Right now, just calculating it is a good thing, but we'll be using it for different things later on. So questions about the population standard deviation before we get to the sample? All right, let's move on. After we do the sample, I'll show you fancy calculator things. They're really not that fancy, but they're kind of cool. Okay, so now, ooh, my battery's going down fast. Sample standard
One
deviation.
sec. Oh, sorry, 1 second. So that answer 9.82, what does that represent?
This right here is our, whoops, this is sigma. This is my standard deviation. This is the average distance each value is from the mean.
Okay, thank you.
You're welcome. All right. So sample standard deviation is done exactly the same way. The only difference is instead of dividing by n, we divide by n minus 1. Now there's some big, complicated, convoluted reason why we do this. But basically what it is doing is, so when we divide by n minus 1, our standard deviation is going to be a little bit larger. So what we're kind of doing is compensating for the fact that we are not sampling the entire population. So it's kind of like our error. We're calculating a little bit of error into it by making that number just a little bit bigger. Because we're saying, you know, there could be some really large values out there or some really small values out there that we didn't sample. So let's kind of err on the side of caution here and make it just a little bit bigger. And that's pretty much what's happening. If you want to Google it, you're going to get some really complicated reasons, but that's like the simplified reason. We don't want complicated. So you're going to do exactly the same, but you divide by n minus 1. That's the only difference. And we have a new symbol. So instead of sigma, it's just a lowercase s, which kind of bothers me, but nobody asked me. I don't like it because a lowercase s and a capital S look almost exactly the same. And I have issues with that. I wish they would have chosen a letter that looks different when it is lowercase than it does when it's uppercase. But nobody asked me, so this is what we're using.
And then when I write it on a piece of paper, it just looks like a 5. Or
That
an
I
S.
have that problem too. And I hate it when like textbook writers use S as a variable and my 5s and S's, I have to like be really careful to make it look good. So yeah, it annoys me, but it is what it is.
So on that previous problem, I got 10.34.
Did you do the n minus 1 instead?
Yes, ma'am.
Yep, that sounds about right. If you made it a sample, that would be about right. All right. So we're going to actually do a sample and we're going to do it with a very small sample. So there won't be a ton of math. So here's a sample of our travel times. So we're going to find the sample standard deviation. So we're going to start off the same and we're going to take each one. So I'm going to find the average of these 3 values. And since this is a sample, it's going to be X bar equals. So my average of these is 22.3. Remember on mean, we generally round to 1 decimal place farther than our actual data. So 22.3 is good. So I'm going to do 5 minus 22.3 squared plus 26 minus 22.3 squared plus 36 minus 22.3 squared. So if you want to be fancy and you want to do less work, if you put it in exactly like this into your calculator, you could do it all at once. Just make sure it looks like this, parentheses and all, and it will work beautifully in your calculator. You can do it all at once. Parentheses are your friend.
To square something, it says X2.
Yes, use the X2 button, and that'll give you the squared. The parentheses are right above the 8 and the 9. I got 500. Uh-oh. 0.67. That right? Looks right.
Sounds good.
Is that what you guys got?
Yes.
How do you go? So I did the exponent for the first number, like 5 minus 22.3 parentheses exponent 2, and then I pressed the plus sign, but then it adds it to the exponent.
So you might need to use the arrows, so the circle thing with the arrows on it. Let me show you. Oh, it didn't log me in. Darn it. So the circle thing with the arrows on it, you might need to push that to the right to get out of it. Mine does, I don't need to do that on mine, but you might need to. So if my calculator, how come it's not signing me in? So so the circle thing above the clear button, push the right arrow to get out of your exponent.
Perfect, thanks.
You're welcome. Sometimes if you use the caret instead of the x squared, it leaves you in the exponent. If this doesn't work, I'm going to be really angry, but I don't know who to be angry with. I'm sure it's somehow my fault, probably for leaving the cable at school. I was just ready to get out of there today. Okay, so now we're going to take this number and we're going to divide by n minus 1. So we're going to divide this by 2. So I'm going to take 500.67 and divide it by 2. So that 2 is n minus 1 because n is 3 because we have 3 values. And you're going to divide it by 2. So that's n minus 1. So I have 250.335. Then go ahead and take the square root of that number. Oh, I said 18. It should be 15. Here we go. It randomly changes colors all by itself. Sorry about that. All right. How'd we do?
Can I clarify 1 second? You
Yes.
you got 2 because we're working with 3 numbers. So n is 3 minus 1.
Right.
Got it. Thanks.
Exactly. Good. Other questions? So you should get 15.82. That's our sample standard deviation. So I would say S equals 15.82 because the sample standard deviation, how come the sample numbers never get pretty symbols? Especially since we use samples so much more than we use population. The samples should get pretty symbols. But that's just my opinion. All right, you good? I'm moving on. All right, before we do this, I want to show you the fancy calculator function. If you have it on your screen, let's use the, I would like to use the test data. And you could always, if it'll let me. There you go. Okay, let me get out of here. All right, so I'm going to walk you through the calculator part. So hopefully you have your calculator in front of you. Feel free to write down the steps if you need to. So in this button right here, it says stat. It's right next to your circles with arrows. You hit the stat button and we want the first option, which is edit. And it's going to bring you to this screen that has lists on it. We want to use the first list. So using your arrows, you arrow over to list, and I want you to arrow up until you highlight the L1. So it should look like this. L1 at top should be highlighted. Once it's highlighted, hit clear and then enter, and it'll clear anything in the list. There's nothing in your list, you don't need to do that. But do not hit the delete button. Don't hit delete, hit clear, enter. Bad things happen when you hit delete. Do not do it. If you accidentally do later on, I can walk you through how to fix it, but don't do it. Hit clear, enter. All right. Now I'm going to just enter my values. I'm going back to the test score. So I have 82. You just hit put. What was that? So you just put in the value and hit enter and it'll move down to the next row. If you don't have it printed out in front of you, just go ahead and look at my numbers. I can make them a little bit bigger if you need me to. Here we go. So you can see them. Don't even worry about L2. I'm going to get rid of L2. That's from something else. I use this at my other school. Okay, so if something's in L2, it's not a big deal. It's not going to mess with anything. Does anyone need another minute to get the numbers in there? Okay, so now that you have all your values in there, hit the stat button. Arrow over till calc is highlighted. So use the right arrow. Calc should be highlighted. And we want the first option, one variable statistics. This is one var stats, one variable statistics. This is what we're looking for. So once again, stat, calc, one variable statistics, one var stats is your first option. And go ahead and hit enter. Your list here should say L1. If it does not say L1, you do second one to put L1 in there. So you would do second one, and then L1 shows up in there if it doesn't already. So right now it should say list L1, your frequency list or FREC list should be blank, and then the word calculate is underneath of it. So let's arrow down to calculate, leave the frequency list blank, arrow down to calculate and hit enter, and then this screen will pop up. This is a lovely, lovely screen. Let me tell you what you're looking at here. The first value is your X bar. This calculator always assumes we have a sample. So it's going to give you an X bar, your X bar 79. That is the same average that we found. This right here, tells us that the sum of all our values is 790. I don't care about that, but that's cool. And then the sum of all of our values squared. I've never used that in my life, but it is a thing. And sum of all our values squared is this right here. These two are the helpful things. So we have our SX is sample standard deviation. So SX sample standard deviation. Sigma X is our population standard deviation. So this is the one we calculated. We got 9.82. This has 9.82. It's really good when our numbers are the same. Our N, this just tells you how many values you have. So there's 10. The 62 is our minimum values. We're not going to talk about Q1 and Q3 yet because we're not ready for that. But this right here is your median, the 79.5. That's the median. And then we have the maximum down here. We'll talk about the other options later. But right now, what we're looking at is our SX and our Sigma X. So though the homework that you're doing, the hand-in homework requires you to calculate standard deviation by hand, this is a great way to check your answer and see if it matches. Questions on the calculator before I go back to the other screen? Okay, going back. Okay, so we already know how to do relative frequency. We already did that. And actually, we don't really need I don't know why this is even in here. We don't need the histogram. We don't need our relative frequency. Let's just move on. Let's talk about the standard deviations between Wendy's and McDonald's and why this is helpful. You're going to have, I believe there's questions on the homework about this. So this is something super useful. So here's these are wait times at McDonald's and Wendy's. So this is how long it takes from placing your order until they give you your order. At least I'm pretty sure that that's what it is. Maybe it's time standing in line. It's not really clear. This could be how long you stand in line before you get helped. I'm not really sure, but these are the wait times. So our sample standard deviation for Wendy's is 0.738 minutes. Our sample standard deviation for McDonald's was 1.265 minutes. And we want to know, we find out that the McDonald's is more dispersed. So McDonald's is larger. So there's more variability in the values. Means that the range and like basically how spread out the data is farther. So Wendy's is more reliable. Even if our wait times were on the larger side, they're all closer to the average. So you would kind of have a better idea of what to expect. So there's something that you can rely on a little bit more. You could predict a little bit more how long it would take you. So smaller standard deviation in this case is good. I believe the homework gives you a question, gives you 2 standard deviations and wants you to kind of analyze it. So think about that the one with the smaller standard deviation is a little more reliable and predictable. Questions before we move on? All right. Variance. This is variance. I have never found anything useful for it other than the fact that occasionally they ask for it. Before you take the square root, that standard deviation squared is the variance. I don't know why it has its own name. I don't know why it is here. If anybody can tell me why it's useful, I would be extremely thankful, but I've never found anything useful for it. You will be asked for the variance in your homework, I believe. All it is the standard deviation squared. That's it. And one of the values, I believe, of your, I don't know, I don't think it shows on the one variable statistics. You would just have to take the standard deviation from that screen and just square it. So the population would be sigma squared and the sample is S squared. So I don't put it on the test because I don't find anything useful for it. It's just a thing. All right. Let's talk about one of my favorite topics, the empirical rule. You do not need to write down all of the bullet points that I give you, but the empirical rule is super, 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 super important. Letting you know, being able to draw the diagram that I give you, super, super, super important. I will draw it 586 times this term, and I'm hoping you draw it at least 10 to 15 times this term. Very important. Did I say it's important? By the way, it's important. Okay, it is roughly bell-shaped. So approximately 68% of our data will lie within 1 standard deviation of the mean. The diagram that we're going to draw a little bit later on will illustrate all of this. So you don't necessarily need to write it down. But, and 68% of our population, so if you take the mean, you add 1 standard deviation from it, or to it, and then subtract 1 standard deviation from it, 68% of your data will lie between those 2 values. About. Approximately 95% of your data will lie within 2 standard deviations of the mean. So add 2 standard deviations to the mean, subtract 2 standard deviations from the mean. In that range, 95% of your data, or approximately, will lie between those 2 values. So you can use the sample data. You just use X bar and S instead of mu and sigma, but I'm not going to be a super stickler about the notation, but I think that, but just know that it's a thing. Understand what they mean when they give you an X bar rather than a mu. Okay, moving on. All right, this is the drawing. You need to draw it, print this out, keep it. Hey, you know, even a really good idea, if you have any of those plastic sleeves, you know what I'm talking about? Like those, like they hook in your binder, those sleeves. If you print this out and put that in there and get a dry erase marker so you can write on this, that would be absolutely perfect. So notice right here, this range in here, 68% of our data lies within here. Then about 95% lies in here. Then 99.7 is within 3 standard deviations of the mean. This still leaves this little, this still leaves this little tiny bit right here and this little tiny bit right there. So that's about 0.3%, but it's 0.15 above and 0.15 below. Make sure your drawing has all of this marked on it, because what's going to happen is they're going to give you pieces of this bell curve and want to know what percent lies underneath of it. So you might have to like add this and this together, or even add this and this together. So make sure you have those percents represented. Another important thing is outliers. So outliers are values that are unusual values. We're going to talk much more about this next week, but outliers are any value that has less than a 5% chance of happening. So outliers are anything that's more than 2 standard deviations from the mean. So anything out here and anything out here, these are where the outliers land. So outliers. I will mention this again next week because we're really going to dive into outliers next week. But since I have the empirical rule, I want to throw that out there. Questions before we do some examples? All right. You're going to get to where you can just like sketch this thing out super quickly. I'm hoping you use it enough that you're able to do that, that you draw it enough that you can do that. Moving on. Okay, we're going to talk about the empirical rule with data. So this is, those of you doing medical stuff, you probably understand this much more than I do. So these are the serum HDL cholesterol of 54 female patients of a family doctor. So this is a sample, and you don't worry, you don't need to know all of these numbers. So this is the sample data. I find that the population mean is 57.4 and the standard deviation, so this should say, oh, it's population mean. I guess it's not a sample. So my mu equals 57.4 and my sigma equals 11.7. And here's my histogram. This is a lovely histogram. It is mostly bell-shaped, and that's kind of what we're looking at here. It's not perfect, but it is decently bell-shaped. It's not super skewed. I mean, maybe it's slightly skewed right, but it's mostly bell-shaped. As I've said before, statisticians don't deal in absolutes. So mostly bell-shaped or roughly bell-shaped, perfectly normal and perfectly good. So what I'm going to do is with my empirical rule, I'm going to label each spot on my diagram. So here we go. So let's take a look. So here's my diagram and here's my labels. So this was the mean. And so what I did was I took 57.4. Let me see what that number was again. 11.7. So I took the 57.4 and then I added 11.7. And I got 69.1. Then I subtracted 11.7. And I got this value right there. Then I did it again. I added another 11.7 and I got this. I added another 11.7 and I got that. Then I keep subtracting it on the other side. And that gives me each of those increments. So you just keep adding the standard deviation and keep subtracting it so you can get each of those pieces. I'm going to erase all of my writing. I'll give you a second. I'm going to erase all the writing because I don't want that all on there. It's just ugly.
So this is the rule every time on the right on the right of the middle number, you're gonna add, and then the left, you're gonna use a negative, correct?
Yeah, exactly. So you subtract to the left and you add to the right. And this is specifically for the empirical rule. Later on, we're going to get a little bit more, we're going to do some calculator things and get a little more exact. So remember that approximately 95% of your data is within 2 standard deviations. So it is not exactly 95, but it is approximately. So if you go to the tutoring center to get help with these values, they're going to give you, because they've already taken stats, they have the calculator functions or the math, the more advanced math. What you want is based on the empirical rule. Until I teach you more, you want numbers based on the empirical rule, because I will mark you down if you're using the calculator functions. Like they're fancy, they'll give you like normal CDF or whatever. I specifically want you to use the empirical rule and the diagram. Okay. So what I'm going to ask questions like this on your homework. Determine what percentage of all patients have serum HDL between 34 and 69.1 according to the empirical rule. So the sections we're looking at what 34, we're looking at this section right here, this section right here, this one right there. Those are the sections we're looking for. So you just take your percents and just add them. 13.5 plus 34 plus 34, and you just add those together. And I bet I could do this in my head, but I don't trust myself right now. It's been a long day. So this is approximately 81.5. So we would expect about 81.5% of our patients or the patients to have serum HDL between 34 and 69.1% or 69.1. So that would be expected based on the empirical rule. So a word of caution before I ask you for questions. This is our last slide. A word of caution. Don't forget this 0.015 at the end. Do not forget those. They are on each end. Both of those are the values that are greater than 3 standard deviations away. So those are way out in the tails. Don't forget those. So make sure when you draw your diagram that you have those in there. Okay, do I have another question? Yeah. Determine the actual percent that, okay, so I'm not going to do that. I would have to go back here and count. Actually, I can do that. Let me see. What are the values I'm looking for? 34 and 69.1. Let's go back. I have to go all the way back. 34 and 69.1. Okay. 34 and 69.1. I'm just going to circle them. Okay. Then we'll count them. And I'm really bad at this, remember that? So let's hope that I don't circle anything that is not appropriate. Oh, all of these, okay. So we're looking at 54 females. So I have 1, 2, I'm gonna count how many are not. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 45 out of 54 have that. So 45 divided by 54. So I have 83.3%. That is not too far off. Where were we over here? So 83.3% was the actual. And we were at 81.5. It is not super far off. So it fits. Since we were mostly bell-shaped, it fit. Now, if we had something that was super skewed, it's not going to fit. Not at all. So you need to have roughly bell-shaped data. And I'm not going to tell you to use the empirical rule if it's not bell-shaped. So don't worry about determining that first. All right. Any questions for on the record while we're recording?
I have a question. When we were calculating about the patients within 3 standard deviations, and you came up with 81.5, I'm just confused. It looks like it's 2 standard deviations, like if you calculate it all. I'm just confused how it it's hard to explain.
Okay, I'm sorry. Go ahead.
No, it's okay.
We didn't calculate 3 standard deviations. We were calculating between these 2 values. So notice 34 is right here and 69.1 is right there. So we were just looking for the area between those 2 values.
Okay, and then my question was more for C. I think that was the slide before or after where we came up with 81 point that okay, there we go, that one. You came up with 81.5 and I was just kind of confused on how it's it like on the graph, it looks like we are going only 2 standard deviations. So each column, so like the 34%, is that 1 standard deviation?
Yeah,
That
I didn't answer C.
Oh, okay. Okay.
Yeah, I didn't answer C. If I was answering C, if we were looking at 3 standard deviations, it's going to be from here all the way to here. So yeah, it would be all of these. So it would be everything except for this 0.15 in the end. So it would be everything between 22.3 and 92.5. So anything lower than 22.3 and higher than 92.5 wouldn't be part of that 3 standard deviations.
Got it. Thank you.
You're welcome. And I didn't even look at the data for that. I don't know if any of them are outside of that. It doesn't look like it. It looks like they're all higher than that and lower than that. It doesn't look like any of them fall outside of there. Any other questions?
Yeah, so for determine the actual percentage of patients that have serum HDL between 34 and 69.1, you
Mhm.
went back, you circled all the ones between that, and then you added it up and you divided by how many that was, correct?
Right,
Just-
exactly.
Okay, thank you.
You're welcome. Any other questions? Any other for on the recording? I will turn the recording off in a moment and we can, and anything else you can ask. We're good? Okay, recording is going off.